So hi everyone. So my name is Dimitri Berthault. I'm from HQS Quantum Simulations. So and so welcome to this talk about how we can use Rust to mitigate breaking changes in scientific software. So first about using Rust to create scientific software. So one big part of it is that most of the scientific community is more familiar with Python than Rust. So to have more potential user, we want to have this crate, your Rust crate as a Python library. So thankfully, there are a lot of tools to do that, like Pyo3, for example, that we use. And also most of the users have some workflow, like for example, Jupyter notebooks that they want to be stable in the long term. So having stability in this library is very important. And now I'm going to present our example for this talk. So it's struqture. So at HQS, what we do is we use quantum computing to simulate quantum system. And struqture is a crate with a Python interface that helps to represent such quantum system. And it can be used with other Rust Python crates, like for example, Coco. That is also one of our crates that can be used to create and represent quantum circuits. And we have partners that have Jupyter notebooks that uses both Coco and struqture together. Before moving on to these breaking changes, I just want to point out one specific issue that can occur when having multiple Rust Python packages that work together. So for example, on the top right corner of the screen, we can see some Python code where we define an operator with struqture. And then with this operator, we create a noise model with Coco. And here on just below, we can see the code in Coco that creates this operator. And we can see that the type in the input is not the same type as here. Instead, we have Py that is the Pyo3 type for any Python object. And why we don't have the same type here is that this +-9 noise operator here comes from this struqture that is a dependency of Coco, while this struqture is the structure from our environment. So this structure is compiled when compiling the wheel for struqture, and this structure is compiled when compiling the wheel for Coco. So it's same crate, but compiled at different times. So this and this are two different objects, which means that if we had this type here, even if this seems to be the same type, it won't see it. It will fail and saying it's different object. So to palliate this problem, we use serialization. So we use this Py type, and then have this from Py function that use the Pyo3 serialization, and then if it fails, it used the from str serialization. So now let's see why we want to add breaking changes. So struqture 1 was out for quite some time, and we accumulate a lot of user feedback. And so, for example, renaming some classes for more clarity, and changes some stuff to make it simpler, and also especially having better error message when the serialization fails, which these changes requires to change the serialization format. So it's a very huge breaking change for what we do. And of course, we want to implement this user recommendation, but we don't want that by implementing the user request, we break the user code. So let's see how we can smoothly implement these changes without disrupting the user experience. So what the idea is to allow both struqture 1 and struqture 2 input for the Python side. So in order to do that, we want to make it easy to convert any struqture 2 object to a struqture 1 object, and convert any struqture 1 object to a struqture 2 object, like vice versa. And to do this, we can leverage a very good tooling of Cargo, that is to have dependency behind feature gates. So in struqture 2, for example, we will have a new feature that is struqture 1 import. And only if this feature is enabled, we have structure 1 as a dependency of structure 2. And once we have this dependency, then it's fairly easy to create a function that creates a structure 2 object from a structure 1 object. And then we do the same thing in structure 1, and this allows us to have these easy conversions without having a cyclic dependency, because if we have a cyclic dependency, we can't have a cyclic dependency. Cargo will complain because it can't figure out how to create the dependency graph. So we have to make them optional dependency with these feature gates. And once we have this function to easily create structure 2 object from structure 1, for example, we can see how we use it in Coco. So the same code as before to create the noise map, the noise model. Here we can do the same thing with the from pi any function that expect a structure 2 object. And if this fails, then we call this from pi any structure 1, that it does the same thing, but it expects a structure 1 object. And so from a user perspective, this means that we can update to the latest version of Coco without having to update to structure 2. So if, for example, one person has a notebook where it defines a very complex structure operator, and then he uses it to create a Coco noise model, he can update to the latest version of Coco without having to update to the latest version of structure and having to rewrite all his code to create the operator. So it's very nice. And here we decided to update Coco to structure 2, but also we could have done the same thing and not update Coco to structure 1 and have the optional dependency. And here there will be from pi any structure 2, and we'll have the same compatibility. But now we also need to return the operator. So if someone wants to get the operator from the noise model, we need to return the correct Python object. So either Python structure 1 object or structure 2. So that's why whenever we create the Coco module, we extract the version of the structure Py package that is installed in the user's Python environment. And we also extract the class of the operator here. And this allows us to create this function, getOperator, that converts operator on the Rust side into a Python object that corresponds to the right version of structure. So we check which version of structure is installed in the environment. If it's 1, then we get the class of the object we want to return. And then we convert this operator to JSON compatible with structure 1. So this method is available thanks to the feature that we talked before. And then we can call the from JSON method on the class and give it the new JSON, and it creates a structure 1 object. And if the version installed is structure 2, then we can just return structure 2 object because Coco uses structure 2. So that's how we at HQS decided to find how to palliate this problem. So thank you for your attention, and all the code here from structure and Coco is open source. So if you want to see more how we did it, you can check it on our GitHub. And if you have any questions, feel free to ask them in the channel for the questions.